Hello, we are in Chapter 6, Section 6.5, Solving Quadratic Inequalities. In this video, we're going to go over problem number 5, in which we are to solve this inequality using test points. So when we're using test points, we first solve the corresponding equation for x. We ask about factoring, of course, once 0 is isolated on the other side, and it is already. So two numbers that multiply to -10 and add to 9 are positive 10 and -1. So we can split our middle term into plus 10x and minus x. Let's rewrite everything else, so we get 5x squared still, then minus 2 equals 0, and we finish factoring with factoring by grouping. So in the first group, the greatest common factor is 5x. Factoring it out results in x plus 2. And to have x plus 2 as a factor in the second group, to make factoring by grouping successful, we factor out -1. Still equals 0. So if the common factor of x plus 2 factor out, we are left with 5x minus 1 equals 0, and by the zero factor property, x plus 2 is equal to 0, or 5x minus 1 is equal to 0. Subtracting 2 from both sides of the first equation results immediately in x equals -2. In the second equation, we first add 1 to both sides to get 5x equals 1, and then divide both sides by 5 to isolate x and get x equals 1/5. So we have two real solutions in here that we are plotting on the x-axis. The alignment of them is what matters. -2 is to the left of 1/5. So let's say -2 is right here, and 1/5 is there. That partitions our real number line into 3 intervals, from -∞ to -2, then from -2 to 1/5, and then from 1/5 to infinity. Now we choose our test points in each interval. Let's say to the left of -2, I will grab -5. Between -2 and 1/5, I will grab 0. And to the right of 1/5, say 1. Always make sure that those test points are indeed inside of those test intervals. And now we check our test points in the original inequality. So starting with x equals -5, we get 5 times the -5 squared plus 9 times the -5 minus 2. And we ask whether this is greater than or equal to 0. Now, -5 squared is 25, and 5 times 25 is 125. -5 times +9 is -45, and then minus 2. The question is still, is it greater than or equal to 0? So let's see what we have. 125 minus 45 is 80, 80 minus 2 is 78, and 78 obviously is greater than or equal to 0. Since the test point satisfies the inequality, the whole interval from which it came, that means -∞ to -2, is a part of the solution set of our inequality. Moving on to the second test point, 0. When we plug 0 into a polynomial, then we are only left with the constant term. So we get only -2. And the question is whether it is greater than or equal to 0. Of course it's not. So our test point doesn't satisfy the inequality, and therefore the whole interval from which it came, from -2 to 1/5, does not belong to the solution set of our inequality. Finally, the last test point, 1, we get 5 times 1 squared plus 9 times 1 minus 2, and ask whether this is greater than or equal to 0. Now 1 squared is 1, 1 times 5 is 5, 9 times 1 is 9, of course, so plus 9 minus 2. Is this greater than or equal to 0? Well, 5 plus 9 is 14. 14 minus 2 is 12. 12 indeed is greater than or equal to 0. Therefore, the whole interval from which this test point came belongs to the solution set of our inequality, and that's the interval from 1/5 to infinity. Now, our inequality is of the form greater than or equal, and therefore the endpoints of our intervals belonging to the solution set are included, because those x-intercepts are the solutions of the corresponding equation, and they satisfy that inequality because of that or equal part. I'm just gonna put big solid red dots at those endpoints to indicate they also belong to the solution set, which is the union of those two intervals from -infinity to -2, including that endpoint -2, meaning a bracket, with the interval from 1/5 to infinity, again including that left endpoint 1/5, so we use a bracket on that side. And that's the solution set to our inequality.